Hello students, today let's start with module 3, chapter 10, Key Management. Key management is basically related to the generation of the key, storage of the key, distribution of the key and maintaining backup of the keys. Basically there are two types of cryptographic algorithms. Symmetric key algorithm that uses only one key for both encryption and decryption. The other one is the public key algorithms that uses a pair of keys called the public and the private key. We are interested in public key management. Public key and private key pairs are used for encryption and decryption of the messages that provides confidentiality, signature generation and verification to provide authentication, and it's also used for exchanging the keys. So at any time if the private key is compromised, then there is no security for the messages. You all should remember that the private key is always maintained with the owner of the key and only the public key is made public. And to know that the public key definitely belongs to a person to whom it is intended to be, the digital certificates are to be generated. And these digital certificates are signed documents that binds the public key to the identity of the person. So these identity may be mail ID, name or postal address or anything. And the entity that issues the certificate is a trusted entity and it's called the Certification Authority, CA. These CA may be government agencies or banks, and the certificates can be of different types for different levels of security. So this diagram shows how the certification authority works. If A wants his public key to be certified, then generates a public key KUA, A's public key, and gives it to the certification authority. The authority generates the certificate and gives it back to A. Similarly, B generates the public key KUB and gives it to CA, and the certificate CB is generated and given to B. Now, when A and B want to communicate with one another, A will give its public key certificate to B and B will give its public key certificate to A. And there are different types of certificates, as I said. So the basic type is to apply for the certificate through the email, and this is useful only when some least security requirements are there. But for high level of security of the information, then the CA has to verify the identity of the person who is requesting for the certificate. So this identity may be mail ID, postal address, etc. Or CA may assign the verification part to the registration authority who already knows the person who is applying for certificate. So this is an example of a bank. Then this X.509 is digital certificate format. This is a well-known worldwide used format for public keys. So International Telecommunication Union has made it standard. It has these fields: serial number, which is unique within the CA, and there are 3 versions, and the issuer information, the person who is issuing the certificate, subject information to whom the certificate is given, and the subject's public key information, that is to which algorithm this key has been given, and the valid period of the certificate, not before this, not after that, and the certificate signature and the associated signature algorithm information. So this diagram, it is not there in your textbook, but this gives a better understanding of X.509 certificate. So the versions, so there can be 3 versions with these fields added: serial number of the certificate, which is unique within the CA, and this gives the information about the algorithm used for generating this signature, issuer name, name of the CA, this is the valid period, to whom the certificate is issued, and this is the algorithm for which the certificate has been given. That is, for this algorithm, this is the key. And if there are some parameters associated with that, then they may be mentioned here. And there can be different CAs with the same name and different subjects with the same name. So there is a unique identity for the issuer and for the subject. And here are some extension fields which we are not studying much in detail. So this is the certificate. Yeah, this is the certificate associated with this algorithm. This is actually a encrypted hash of the information in all these fields. So this will be encrypted by the CA's private key. So this is the certificate revocation list which we'll be learning in the coming sections. This is the diagram given in your textbook. So this gives us an idea about how the X.509 certificate looks like. So this is the version and this is the serial number and this is the signature algorithm which indicates that the algorithm used for signature, that is the MD5 algorithm, is used with RSA encryption. This is the issuer name, country India, state Maharashtra, etc. This is the valid period, subject's name, country India, state Goa, etc. And this is the public key information. That is, this certificate is given for the RSA encryption algorithm. Key size is 1K bits and this is actually the key. And here we have the signature and the signature is done with the MD5 algorithm with the RSA encryption. So whenever A obtains B certificate, then A needs to perform certain checks before using the certificate. So he has to check for the identity whether the certificate belongs to B and is the certificate valid, is there a signature, and to verify the signature, the receiver should know CA's public key because it is encrypted with CA's private key. So the CA may be globally known or may be known only to the community to which A and B belong to. In this case, A should have access to CA's public key, only then it can be verified. So this is about the digital certificates. Next, we'll be learning about the PKI, that is public key infrastructure, in the next class. So students, try to understand this, and if you have any doubts, you can definitely come back to us. Thank you.